Hey everyone, welcome. Today we're going to tackle one of those classic algebra problems. You know the one. But don't sweat it, because by the end of this, you're going to have this super simple visual trick to solve them every single time. Seriously. So let's just jump right in.
Yep, I'm talking about that one. The dreaded mixture problem. You know, where they ask you to mix two different solutions, or two kinds of trail mix, or whatever. And yeah, I get it. They can look super intimidating. But I promise you, there's a really easy, visual way to break it all down.
And this is the key right here. We're calling it the bucket method. And honestly, it's like your secret weapon. It takes this big, confusing paragraph of words and just turns it into a straightforward, solvable math problem. It's awesome.
So what is this thing? Well, it's all about just picturing it. Imagine you've got two buckets, right? And you're pouring them into one big final bucket. For every single bucket, we only need to keep track of two little things. First, the total amount of stuff in it, like how many liters or pounds. And second, how much of the one pure ingredient we actually care about is in there. That could be acid, it could be money, it could even be cashews. Doesn't matter.
And what's so cool about this is that it gives us the same two equations every single time. It's like a formula. First up, you have the amount equation. It's exactly what it sounds like. The total stuff from bucket A plus the total stuff from bucket B, well, that equals the total stuff in the final bucket. Super simple, right? Then you got the ingredient equation. This is where we focus on that one special ingredient. The amount of, say, acid from bucket A plus the acid from bucket B has to equal the total amount of acid in the final mix. And that's it. These two equations, that's all you're ever going to need to solve any of these problems.
Okay, so theory is one thing, but let's actually see how this works in the real world. We're going to walk through 3 examples together, and we'll start with a pretty basic one just to get the hang of it.
So here's problem number 1. This is a total classic chemistry lab type of question. You've got two solutions, one's kind of weak, one's really strong, and your job is to mix them to get a very specific amount of a medium strength solution.
Okay, let's use our bucket method. The amount equation, super easy. We'll just call the amount from the first bucket X, and the amount from the second bucket Y. So naturally, X plus Y has to equal our final goal of 12 liters. Makes sense, right? Now for the ingredient equation. Here we're tracking the acid, so that's 10% of X plus 40% of Y, and that all has to equal 20% of our total of 12 liters. Look at that. We literally just translated the word problem directly into 2 clean equations. All that's left is to solve the system.
So you go ahead and solve that system, and boom, you find out that X equals 8. That means we need 8 liters of that weak 10% solution. And hey, if the total is 12, that means we must need 4 liters of the stronger 40% stuff. Simple as that. First one, done and dusted.
All right, let's step it up a notch. This time, we're talking about money, about finance. But you're going to see that even though the story is different, the math behind it, it's exactly the same. This time, our buckets are just investment accounts, and our ingredient is the interest we earn.
This is just a perfect example of how powerful this method is. Check it out. The amount equation is just our total cash. The money in the safe account, let's call it S, plus the money in the risky one, R, equals our grand total of $5,000. Then the ingredient equation tracks the profit, the interest. So 2% of S plus 8% of R has to equal the $220 we made. See that? It is the exact same 2 equation setup.
And when you solve this system, it tells you that R, the amount you put in those risky stocks, was $2,000. Well, that means the other $3,000 had to be in the safe account. See what I mean? The story changes, but the math stays the same.
All right, last example. This time, we're talking about a dry mix, like nuts or something. We're calling this one advanced, but honestly, it's only for one tiny reason. There's just one little extra step we have to do at the beginning before we can set up our equations. So here's the so-called tricky part. The problem doesn't just hand you the total final cost. Instead, it gives you the weight and the average price per pound. So all we have to do is one quick calculation first. We just take the 20 pounds, multiply it by $5.50 per pound, and that gives us a total final value of $110. And that is the key number we need for our ingredient equation. And now that we have that number, setting this up is an absolute breeze. Our amount equation is all about the weight. Pounds of cashews, let's call it C, plus pounds of peanuts, P, equals 20 pounds total. Easy. Then the ingredient equation is all about the cost. $10 times our pounds of cashews, plus $4 times our pounds of peanuts, equals that grand total of $110 we just figured out.
We solve that system one last time, and what do we get?
C equals 5, so we need 5 pounds of cashews. And of course, if the whole mix is 20 pounds, that means the other 15 pounds have to be peanuts. And just like that, we've totally conquered all 3 levels.
Okay, so now that you've got the method down, I want to quickly talk about 2 really common traps that people fall into with these problems, just so you can watch out for them and not make the same mistakes.
Listen up, because this is, without a doubt, the #1 mistake I see people make. In that first acid problem, people will often write that the ingredients add up to just 0.20, just the final percentage. And that's wrong. No. Remember, it has to add up to 0.20 times of the total amount, so it's 0.20 times the 12 liters. Please, whatever you do, never ever forget to multiply that final percentage by the final total.
Oh, and here's another quick heads up. If a problem ever says you're adding a pure ingredient, like pure acid, just remember that means it's 100%, so you use the number 1.00 in your equation. And on the flip side, if you're adding something that has none of the ingredient, like adding pure water to an acid mix, well, that's just 0%. Easy enough.
So you might be thinking, okay, why are we even learning this? Is this just going to be on a test? And the answer is absolutely not. This kind of math is actually critical in some really, really important jobs out there.
I mean, think about pharmacists and nurses. They use this exact type of math every single day to figure out things like IV drip concentrations and medication dosages. You know, if they only have a 10% solution and a 50% solution in their supply cabinet, but the doctor orders a 15% solution for a patient, they have to do this exact calculation to make it. And of course, chemists in a lab, they're doing this stuff all day long for their experiments.
And really, this is the bottom line. In fields like that, there is zero room for error. Getting this calculation wrong isn't about getting a bad grade on a quiz. It could actually have really serious consequences for someone's health. So this isn't just some abstract math problem. It's a tool that can, quite literally, save lives.
So next time you're in the kitchen mixing up a recipe, or you're at the gas station choosing a fuel blend, or maybe you're just looking at your own investment portfolio, I bet you'll start to see these mixture problems pop up everywhere. And the cool thing is, now you actually have the tool to solve them. So my question for you is, what are you going to solve for next?